Greetings to all. Today I am going to present the topic of IC 743 voltage regulator. Before studying IC 723, let me know disadvantage of fixed voltage regulator. The first one is fixed voltage regulator do not have short circuit protections, and the second one is this output voltage is not adjustable. These limitations overcome by IC 723 voltage regulator. IC 723 regulator is vessels and widely used for voltage regulator IC. Now let's see the features of IC 723. The unregulated DC power supply voltage input can be between the 9.5 volts and 40 volts. It provides adjustable regulated and output voltages. The next one is the maximum load current is 15 milliamperes. It is operated with both positive and negative supplies, and the internal power supply is the 800 million volts. It has built-in the short circuit protections, and it is low power temperature drift and high ripple rejections. These features are suitable for many voltage regulation applications. So this slide shows the functional diagram of IC 723. The IC consists of the differential internal block which work together to provide the stable and unregulated output voltages. The major block is include reference generating block, error amplifier, series pass transistor, and current limiting circuitry. Let's discuss each block in detail. The simplified functional block diagram of IC 723 is divided into four important sections. The first one is reference generating block. The second one is error amplifier. The third one is series pass transistor, and the final one is circuitry to limit the current. Each block performs specific functions to maintain the regulated output voltage. Let us discuss the reference generating block. This block consists of a temperature compensator, Zener diode, a voltage current source, and a voltage reference amplifier. This Zener diode generates fixed reference voltage internally. The constant current source ensures that Zener diode operates at a fixed point. This reference voltage is applied to the non-inverting terminal of the error amplifier. The unregulated input voltage, represented as a plus or minus VCC, is applied on both voltage reference amplifier and the error amplifier. These blocks provide the stable reference voltage. The next one is error amplifier. The error amplifier is a high gain differential amplifier. It is two input. First one is inverting and the second one is non-inverting. The non-inverting terminals receive the internally generate reference voltage. The inverting terminal received a regulated output. The error amplifier combines the two voltage and generate an error signal to maintain the constant voltage. Now let us see the series pass transistor. The Q1 is internal series pass transistor. It is driven by the error amplifier. The transistor acts as a variable resistor and regulated the output voltage. The collector of transistor Q1 is connected to the unregulated power supply. The maximum collector voltage is Q1 is 36 volt. The maximum current supplied by Q1 is 15 milliampere. Therefore, the Q1 is major role in the voltage regulation. And the last one is the circuitry to limit the current. This block provides current limiting protections. The internal transistor Q2 is the current sensing and limiting. Under the normal condition, Q2 remains off. It turns on when the current exceeds to predetermined limit. This protects the circuit from the excessive current. The regulator can provide low voltage and low current outputs. The load current ranges is from the 2 to 7 volts, and the load current is 150 milliamperes. Thus, the circuitry ensures the safe operations of the regulator. This slide shows the IC 723. Each pin have a function such as input supply connections, outputs connections, current sensing terminal, reference voltage terminal, and compensation terminal. Understanding the pin configuration important design to using IC 723. This circuit illustrated the IC 723 used low voltage and low current regulator. In these configurations, the output voltage can be adjusted to obtain the required low outputs. This circuit provides regulated output while maintaining the stability and protection features. This application is suitable for low current electronic circuits. In this circuit, R1 and R2 form a potential divider between the reference voltage and the ground. The voltage across the R2 is connected to the non-inverting terminal of the regulated IC. Since the gain of the internal error amplifier very high, the output voltage fed to the inverting terminal through the R3 becomes approximately equal to the non-inverting voltage. This principle helps to maintain the desired voltage output. The further values of R1 and R2 is generally chosen the 1 kilo ohm to 10 kilo ohm. The value of R3 is selected using the given design equations. The voltage drop across the RSC proportional to the current. This RSC helps to the current sensing and over protection. In this circuit, the current sourcing capacity can be increased by adding an external transistor Q. The transistor allows to drive the higher load current than the internal transistor allows. Therefore, the IC723 is the used in application requiring high output current. To conclude the IC vessels, the voltage regulated IC that provide the adjustable output voltage, short circuit to protections, current limiting, and excellent regulation characteristics due to the advantages. It's widely used in the power supply applications. Thank you for watching.